All right. Hey everyone, welcome to another deep dive. Today we have with us Alexei from Interlay Protocol. Welcome, Alexei.
Hey, thanks for having me.
Yeah, so I guess the first question, we'll kind of just jump right into it. How did you get into building? I think you had said, like, would you call it an interoperability solution or a bridge, whichever one you want to call it?
I mean, it started as a bridge, right? But it actually turned into quite a bit more. So today it's really a middle layer between Bitcoin and like the multi-chain ecosystem that kind of focuses not just on bridging Bitcoin to other chains, but really allowing people to build on Bitcoin and also use Bitcoin for like mainly in DeFi initially, and then also in other decentralized use cases. So it's kind of a full stack of things kind of built on top of the bridge.
Yeah. Well, I guess, how'd you get into it? Bitcoin, I always love people who started with Bitcoin. Did you start in that ecosystem and then come over to EVM land?
Yeah, so I got into kind of being quite excited about Bitcoin in 2015. So I come from a computer science background. I was doing security research, and my bachelor's thesis was supposed to focus on obfuscating Tor traffic and hiding it behind Skype traffic. And obviously the best place to look at that, like how people use Tor, like, and everything was, well, okay, look at the remnants of Silk Road, and bumped into Bitcoin there. And that Bitcoin kind of was the other option that I had for my thesis. And I just did a full deep dive into that. But actually got really excited, not about Bitcoin itself, but Namecoin. So how we can, build decentralized identities and like decentralized DNS systems. And then, yeah, fast forwards, I spent like years since then working in research on various Bitcoin topics, ranging from security of merged mining, decentralized mining pools, trying to build things like then, weak block solutions and like Velvet. So like meta protocols of basically what you see today with color coins and BRC20s. And then I, by coincidence, just ended up getting a PhD position at Imperial College in London. And that was funded by blockchain.com, who was kind of suggesting, well, we should look into payment channels. So we looked into that, but also into making Bitcoin interoperable. And that's essentially kind of what set us on this path to create interlay, and then like before that, a really fully decentralized Bitcoin bridge.
So, okay, well, I'm gonna have to pick your brain a whole lot on a lot of that stuff, because that's that sounds super interesting. Yeah, I mean, when did you found Interlay? And is it just yourself?
So it's two of us. Dom and myself were the first two PhD students in the Imperial College blockchain lab, and we started Interlay in late 2019. So kind of 2 years into our PhDs. We were mostly finished with research by that time. And yeah, we thought we'll write up the thesis, while running the company, which obviously took much longer than anticipated then. But yeah, we've been doing this it's going to be 4 years in October.
Okay, super cool. Yeah, so remind me at the end, I'll ask you, since you're a merge mining expert, we have to ask you about Eigenlayer near the end.
Yeah.
Sure. All right. But yeah, so I guess we can just kind of jump right into it, I guess, and we'll start figuring out how it works. So what is the ideal use case currently? So we'll go with the base protocol, if you will. Would it be bridging Bitcoin or bridging two chains together?
So I think starting with the bridge is definitely useful, because that's where the biggest problem lies, right? So
yep.
The core use case of Interlay and the mission is to unlock more use cases for Bitcoin, but we cannot do this on Bitcoin, right? So building on Bitcoin today is quite limited. Bitcoin script allows it to do a few limited things, like time locks, hash locks, but you can't really build a lending protocol. You can't do auctions, and there's a lot of things that are not supported, and it's expensive, and it's slower. So the goal was, well, let's make Bitcoin more useful, and do that by not sending people to Binance, but get them into DeFi on Ethereum, Polkadot, Cosmos, and so on. And that essentially is what the core kind of bridge at interlay does. So interlay itself is a standalone layer 1, and it's connected to Bitcoin through a trustless bridge that allows people then to use Bitcoin for more things.
So we'll draw Bitcoin over here, and then we'll draw a big interlay contract down here. So the problem is someone over here will, over here, our user, they want to use their Bitcoin in a lending app on Ethereum, right? This is like the core problem, or they want to create a lending app over on Ethereum with their Bitcoin. So they need to somehow get their Bitcoin over here. And what they're going to do is like kind of the standard bridging thing. I'm guessing they'll deposit it into some multi-sig on Bitcoin.
Well, so there's the kind of two things here. So in theory, you can do it like you can pass through Ethereum as well, but you can also just have a lending app directly on interlay, right? Because it is a standalone platform.
Oh, so you could just build it here, right? Okay.
Exactly, yeah. So you can also route through it to Ethereum as well, but that requires another bridge, which we can talk to a bit later. But let's assume like there's just like a black box you want to go into.
You want to go to
interlay, and then that has like interlay is your main interfacing point.
Okay.
So, and then what you do is you don't deposit into multisig. So the big difference between interlay and things like WBTC or formerly RemBTC is that there is not only one operator, but anyone can spin up a so-called vault. So it's much closer to how MakerDAO's vault design looks like than to multisigs. So you have an interlay today, a permissionless set of vault operators. Anyone can spin up a vault, and the only thing they need to do is lock up some tokens. And these tokens are collateral assets.
Okay, so they would lock collateral. And how much is it, or is it variable?
So it's variable. There's like some very low minimal deposit amounts right now. And then the amount of collateral really determines how much Bitcoin you can receive. So that determines how much Bitcoin you'll be securing.
So do they lock the collateral on the Bitcoin chain, or this is on interlay?
On the interlay chain.
On interlay.
So they lock it on interlay in the interlay smart contract.
Okay. And then is this your token they're locking, or is this?
No, so this is essentially blue chip assets. So we don't use the interlay native token because it's very dangerous. Like if you look at Luna, what happened there, right? If you use your native token, like as insurance, it's risky because what's the first thing that will dump if something happens to that bridge? It's the native token. And then obviously if you start liquidating that token to come out of this problem, you just throw more of it on the market and you get into this death spiral. So no, that's why the interlay IBDC bridge uses different collateral assets. So right now we support USDT and DOT, and we'll be adding more deep liquidity, so-called, I guess, blue chip assets in the near future. So there is no limit to what can be used. It's all decided by governance, like in MakerDAO, essentially.
So is this a Polkadot chain?
Interlay connects to Polkadot right now to bootstrap security. And essentially also benefit from being able to talk to other chains. But it's like, it's essentially, Polkadot is like our operating system. So we use that for consensus. It's not too dissimilar to using merge mining. So we plug into Polkadot validator set and they validate the chain essentially. So instead of the interlay users and network having to look for own proof of stake validators or doing merge mining, the network plugs into Polkadot and uses it for interoperability, and also like we get native USDT for that. So it's you're a part of a bigger kind of network.
Yep. Sorry.
Yeah. No, go ahead. So it's like it's not too different from being an L2, because it like being a Polkadot parachain is similar to being an Ethereum L2. Like technologically wise, it has a few advantages like decentralized sequencers and so on, and a bit more like shared security, but it's very, very similar to just being an Ethereum L2.
I don't know if I agree with you there, but I'll let it slide. We'll let it slide today.
So like conceptually, conceptually, like
conceptually for people watching. Yeah, no, I mean, okay, well, I'm just curious. Like that's like technically, obviously, Bitcoin that you're connecting to is not a Polkadot parachain.
Yeah.
So like you're not just using XCM, and theoretically, you could have built this on say Cosmos or an EVM standalone or something like that, too. It's okay. So we're locking up some USDT, some DOT as collateral, and then what happens?
So now that we have some vaults and they have locked up collateral, the system knows, okay, we can allow users to bridge X amount of Bitcoin. And then you as a user can come to the platform and say, well, I'd like to bridge BTC. And it looks and feels like depositing into an exchange or bridging through a centralized bridging provider. You get a deposit address, you send Bitcoin, you receive IBTC. That's what the user sees. What happens in the background, step by step, is you, as a user, send Bitcoin to one of these vaults or multiple vaults, depending on how big your order is.
Okay.
And then you submit a proof that you actually sent the Bitcoin. So you submit a cryptographic proof from Bitcoin to the interlay smart contract.
My markers are all up. Cool. So then, you send BTC, and then submit proof to, and then the proof. What does that look like? I guess that's the.
So the proof is a light client proof. So it basically works just like SPV on Bitcoin. So it's the same mechanism that wallets use, right? Like, for example, mobile wallets, because they don't download the entire Bitcoin blockchain. They only download the block headers, which is the metadata that links the blocks together. And it has this Merkle tree root hash, which is a commitment to all the transactions included in that block. And that allows you then to prove that your transaction, let's say, was included in block 20,000. So what interlay does, it has a Bitcoin light client built into the chain as a smart contract, and it tracks the Bitcoin chain. Every new Bitcoin block header is tracked on the interlay network, and then anyone can submit transaction proofs. So you can prove to the interlay network that, hey, I've made a Bitcoin transaction.
And for Bitcoin, the consensus is what, like longest chain?
Just like a Bitcoin, just the same rules as in the Bitcoin light client. So longest chain, or longest chain / heaviest chain in Bitcoin, because they're all same weight essentially.
So versus like a proof of stake would be like you have the set of signatures or.
Correct. Yeah.
So super cool. So then they would submit it here, and then you would release IBTC with the proof, and then basically like this person's now holding the Bitcoin, and if they steal it from the system, you can check that because somebody would submit a proof that they transferred it out or something, and then you could slash them, right?
So the thing is, we initially had much stricter rules. So initially when interlay launched, you were not even, as an operator, you were not allowed to touch the Bitcoin at all unless the system would permit it. The thing is that it doesn't really change security guarantees. The security is based on the collateral being there. So right now we changed that, improved it a bit, also in favor of security, because now the vault operators can move it into cold storage, right? Before they would you don't want to force them to hold Bitcoin in a hot wallet. So these guys, they store Bitcoin, they can move it into a cold storage, they can move it around as long as they return it to the user when the user wants to go back. So if a vault operator,
so the user can get that Bitcoin, or can he like
any user?
Any user. So like if this IBTC got transferred over to a new guy, he could come in and say like, give me some Bitcoin, and then would the protocol call a specific guy or just whoever's there?
Any guy, any vault.
Any guy, any vault should be able to send him the Bitcoin. And if he does, if no vaults respond or something, then you can slash them, basically.
Exactly.
Yep.
So it's time-based. So the vault, upon redemption, what a user does, so like now you have IBTC, you can use it in DeFi, it's fully fungible. You can put it into protocols on Polkadot, and with bridges, you can move it to Ethereum and other chains. The assumption here is that it should be easier and much more like widely adopted to have decentralized bridges between smart contract capable chains in the future. So you'll be able to just bridge it over to Ethereum and Cosmos and so on. But when you want to go back, so let's say you received IBTC and you want to have Bitcoin back.
Okay.
What you do is you lock it in the interlay smart contract, so you return it.
Okay.
And then the system will pick one or more vaults and tell them, okay, send the Bitcoin now. And you now have a certain amount of time between 12 and 24 hours. This is a system parameter that can be changed by governance. And the vaults now must return the Bitcoin to you on the Bitcoin side.
Okay.
And the question now is, how do you figure out if the vault actually sent the Bitcoin? And in this case, the vault must prove that it actually behaved correctly. So whichever vault is selected, exactly, to return the Bitcoin must then submit a like client proof to the relay, to the like client, to the interlay smart contract. And if that doesn't happen within a certain period of time, we assume, okay, vault misbehaved, and the user can do one of two things: retry with another vault, and the vault gets like penalized a little bit, or swap, take the vault's collateral at a premium rate.
Nice. Cool.
So I'm not sure if this helps in the explanation. I'm still experimenting with that explanation, but it's very similar to a lending protocol.
Yeah.
So the user borrows IBTC against physical Bitcoin. The vault borrows physical Bitcoin against collateral and gives an IOU to the user, and the user hence can always trigger repayment.
Yep. So I guess
it's similar in that sense.
Yep. So I'm guessing, do you have an oracle then for the Bitcoin price versus the collateral?
Yeah. So that is the unfortunate thing, that just like all DeFi protocols, we still need to rely on a price oracle. There is, unfortunately, we really tried for a long time, but like
they're not that bad.
In this economic security model, you need a price oracle. The good thing is, the more Bitcoin is bridged over, the more volumes you have on decentralized exchanges, the more reliant the price source comes, like decentralized price source becomes, long term, right? But for now, yes, you need an oracle.
And who do you guys use?
So right now we are integrated with Dia.
Okay. I think you're the first person I've met that has said Dia, so that's cool.
Yeah, I mean, they've been around for a while, and they've been super proactive, and they have this pretty cool new thing where they also, like, they don't only look at the exchange rates, but they also, like, they have a special feed for liquid staking assets, and they also have a special price feed for IBTC where they also look at the collateral backing. So they've been quite innovative in that regard. So if you are a dApp that integrates IBTC and you use Dia price feeds, they will tell you not only, okay, what's the IBTC price on DEXs, but also look at, is it still backed by collateral and hence truly like secure.
Well, would you need the IBTC price? You would want the BTC price, right?
So we want the BTC price as interlay, but your dApp that uses IBTC should, of course, never use just the Bitcoin price, but you need the IBTC price. Right?
Okay.
So it needs to be specific. We recommend IBTC because, God forbid, something happens, it goes up in price or it depegs a bit. You don't want to just have a hard peg to Bitcoin. That will, causing inefficiencies.
Nice. Yeah, no, this sounds super cool. I guess the one question I would have is, like, do you guys have to keep this up to date then? Like, you have to submit, you have obviously a relayer that has to just do this all the time.
Yeah. So of course, like just like your mobile phone would, your Likeline wallet will ask full nodes, hey, can you give me the latest block data? But since this is a smart contract on interlay, it cannot call outside, right? So what
Right.
we do is we have vaults, and we have every vault by default, every vault client, if you use the default interlay client, will submit block headers. So we need at least one honest and online node. So anyone on the internet can spin up a relayer basically and submit the block headers. It's once every 10 minutes. It's very cheap. So as long as one person does it, it works. Because like the assumption is like if you want to attack interlay through this route, you can either try to prevent everybody from submitting block headers, which is difficult, right? You have to kind of isolate the entire interlay network. So it's not one client, but it's all the nodes in interlay need to be isolated, which is very difficult. Or you need to attack Bitcoin, which is even more difficult. So that's kind of the security model there.
Well, I mean, I know for this one, like this is one of the reasons, like I think like with TBTC on Ethereum and some other ones, like they've just had a whole lot of trouble keeping, or what was it, BTC Relay way back in the day? Like nobody wants to submit block headers because it gets pricey.
So that's also the reason why we didn't end up deploying this on EVM. Like the first proof of concept in 2018 was actually on Ethereum, and we ran the numbers, and it's so expensive to maintain that. So our assumption was like the reason why we built like a standalone chain was cost. So we could customize and say it's specialized to store Bitcoin block headers. We'll make that operation cheap. And we wanted to use Bitcoin like Rust libraries. We didn't want to re-implement all the parsing logic and all the things in Solidity, which is, risky.
So yeah, hence you used Polkadot, which uses Rust.
So yeah, well, the underlying framework is Substrate, which is actually used like by Near and by Polygon Avail. So it's used like quite a bit outside of Polkadot as well.
Yeah, no, cool. All right. And then I guess the other question, if we're talking Bitcoin, like what do you guys, you were saying it's every 10 minutes, but like how do you guys wait for finality on this? Like how long do you have to wait for Bitcoin to be final?
So right now, the design assumes that, bridging should be slow. It's like crossing a chasm. Like you want to take your time. You want to be sure that a Bitcoin's actually there, because cleaning up the mess, if we mint some IBTC and then there's some double spending on Bitcoin, is so painful. So basically what it does, the Bitcoin relay on interlay, so the light client looks at the Bitcoin block headers, waits for 6 confirmations right now. This is again a system parameter, and we would highly recommend applications that use this. You can set a higher requirement. So if a dApp that uses this live client to verify Bitcoin transactions, you can set a custom threshold. So if you have a very big deposit, you could require users to wait longer. On interlay, it's like 1 hour. And in addition, we also track like interlay's blocks. So even if there's if there's a fork on Bitcoin, so somebody manages to quickly mint 6 blocks on Bitcoin, which is very unrealistic already, right? And then mint a fork, push that to interlay. We still will wait for an hour because we track kind of additionally the blocks on the interlay side, just to be sure, like within the hour, somebody will likely give us the real Bitcoin chain, right? So somebody will keep submitting the valid real main chain block headers and we'll catch the fork. So it's purposefully slightly delayed right now. Honestly, right now, like it's probably not going to happen, but you never know. And like the system is built in a way that it kind of would catch a potential fork attack.
Yep. Well, I mean, like if this was live during, the Bitcoin Cash hard fork, like it would have just stayed on the main Bitcoin chain and been fine.
Yeah.
I mean, the only downside would be like if you're in IBTC, you don't get Bitcoin Cash, so you couldn't sell it.
Well, I mean, it depends, right? So if you have been around back then, right, and it splits, you have Bitcoin and Bitcoin Cash. IBTC is just a representation of your Bitcoin. So the Bitcoin's still there. So essentially, you would have to go ask the vault to send you Bitcoin Cash as well. But what you could do as interlay as a DAO could do is fork the contract and say, well, now we also support Bitcoin
Okay.
Cash. And in fact, it's not even forking a contract. We kind of thought about, adding more Bitcoin forks and being able to support different versions. Also, like maybe like Bitcoin that's coming directly from the mine, or Bitcoin that's mined from a mining pool that's provably green. So it's built in a way that you can quickly add a different Bitcoin version, and just add a different light client, and you're good to go.
So you would
easy
enforce that? Like,
fork.
would you slash them though? Because that would be the question. Because like, this happened like whenever the Bitcoin Cash fork happened, like all the exchanges just like dumped their tokens. It's like the exchange employees were going around like basically using the private keys.
You wouldn't slash them, right? I mean,
yeah.
If the vaults basically go dump the Bitcoin Cash, I mean, it's hard to control out of bounds. The interlay governance system, which the vaults are part of, could vote on, saying, well, it might be useful to actually extend this to a Bitcoin Cash bridge as well back then, right? Or like, let's call it Bitcoin, I don't know, Cash 2.0 if they fork again. But yeah, it's like hard forks are messy. So you always have to deal with them out of bounds.
Nice. Okay. No, that was super cool. I mean, but you guys, this is one of the benefits of having like your own L1. You could theoretically fork your own L1 to handle it, right?
Yeah.
Yeah.
Yeah. So
yeah, kind of like you were saying, just split. Super cool. Okay, so and then what did I miss on this piece? Anything? Or do we want to move on to the next?
One of the challenges, we can talk about, we come from academia, we tend to be quite honest about the drawbacks and advantages. So advantages are clear, right? This is economically secure. As long as, the collateral value is higher than the Bitcoin value and the liquidation mechanism works properly, your Bitcoin is insured, and like vaults have no incentive to steal. So it's not only that you have partial insurance, like with FDIC and like when you have your money in US banks, but it's 100% insured. Plus, on top, you actually get a small premium if the system fails. Now, that's all great, but it comes at a cost, right? So it does come at a cost, and the cost is the capital efficiency. So vaults need to have a reason to lock up the collateral, right? They have other opportunities in DeFi where they could put their USDT, put their DOT, put their ETH, and you're suddenly, the bridge is now competing the DeFi protocols, which is quite unusual for a bridge to do, right? For like the capital. So how do we solve that? There is essentially three ways of doing that, right? Or like two ways. So one is like, okay, try to get rid of the collateral requirement, which leads it down a path of reduced. So like that path has two outcomes. Either you end up with reduced security and you bet on statistics. So you do like a big threshold signature model, you do a big multisig, and you just hope that the majority will be honest, and that with MPC threshold protocols that, all know like your key rotation works properly, and nobody in the future goes like old nodes don't try to recover the old key, and like you need to like you bet on like that. That's your trust model. So statistical security. You want what are the chances of this breaking? Or you build specific use cases. So with the rise of DLCs, so discrete lock contracts on Bitcoin, and other like smaller things, smaller tools, you can actually try to build very specialized use cases. So that's something we're exploring right now, where you kind of time lock your Bitcoin and you have some predefined slashing conditions or unlock conditions on the Bitcoin side. But what you break there is fungibility. The moment you do some time locks, multi-sig kind of shared custody setups on the Bitcoin side, it's no longer fungible. So you cannot easily send the wrapped Bitcoin around. So that works if you say, okay, it's not like a wrapped Bitcoin asset that you can use in trading and lending to buy NFTs, but it only works for, let's say, a Bitcoin-backed stablecoin and nothing else. So it only works for that. So that's one route. Again, realistically, what you end up is like slightly better security than a big multi-sig, but still kind of statistical security. There is always some bottleneck, unfortunately. So that's your options if you want to get rid of collateral. We spent a lot of time on that. We proposed a kind of one model that kind of goes, but that works similar to DLCs, like before DLCs were used. But now we're actually exploring something else, and that is the second route is, okay, let's say we need the collateral. Let's accept the fact that collateral is really what makes the economic security work. how can we make it more useful, right? We have this pot of money sitting there, not doing anything. How can we, make it more useful? How can we put it to work? So, and there's like 3 things you can do, but the 2 most interesting ones are using liquid staking, or as Eigenlayer might call it, restaking. In the sense, it's like 2 sides to 1 coin. You, instead of asking vaults to put in like DOT or ETH, you allow them to stake it first and then accept liquid staking as collateral. So this does involve some additional counterparty risk with a liquid staking project or whatever, but it is so much more capital efficient, and you essentially don't compete with the base layer staking rewards anymore. So that's one way to do this. And this is in fact something that is already live and we're doing on a smaller network.
Well, wouldn't you say like, like I see this with Ethereum, everyone would say like with Eigenlayer, you could, this would be more capital efficient because now you're not competing with DeFi protocols. But like if all DeFi protocols move to just using staked ETH, then you're still competing with DeFi protocols, right?
Well, yes and no, because there's not that much where it makes sense to use staked ETH. Like lending out staked ETH, well, you don't get the stake, depending how it's implemented, you don't get the staking rewards anymore. So it really depends what you do, right? So this whole new field of like liquid staking DeFi is quite new. You need to really, normal AMM pools don't work anymore. You need something like a balanced linear pool. Yep. And they need to figure out who is the one actually earning the staking rewards. Is it with LP positions? Okay, it's the person who supplied. But I come in, like I actually have to split my position. So, you need to then figure out reward redistribution and so on. With lending, who gets the rewards is if I supply my STETH into compound, like what's the best way to handle that?
But we'll get
Doesn't really make sense anymore, right? Because, well,
yeah.
But you're borrowing what if you borrow it? Should you be getting the STETH rewards then, or should I be getting it? So basically, yes, you can compete, but in the end, it's like lending. So in this case, you're running a node and you're getting interest on it, right? If you prefer higher risk and you put it into an AMM pool, right, where it's higher risk because of permanent loss and so on, sure, right? But you don't compete with the base layer staking rewards, which are like nearly risk-free, which is the biggest challenge. Once you compete only against DeFi protocols, it's easier because the bridge has pretty low risk. It's like making sure your collateral position is high enough and just not stealing, right? Which is, just don't steal and then you'll be fine. Yeah, so that's one way to do that. Another interesting thing, and so that works well with like liquid staking, works well with layer 1 proof of stake assets. The other thing is, well, we don't only have like .eth, we also have stablecoins in there as collateral. What can we do with them? Well, interlay has a native lending protocol. Or you can use it with any lending protocol essentially. But let's use a compound V2 model as example. You would, as a vault, you would supply your stablecoins into compound V2 lending. You get your C token out, which is a representation of your stablecoin supply position. And instead of now putting it back into the compound protocol to borrow against it, you take that C token, you put it up as a vault collateral, and you borrow physical Bitcoin by running the vaults. And you earn bridge fees, and you earn now interest on lending out your collateral, your stablecoins. Sure. And then if you want to go more exotic, and this is something that is quite early, and we don't see us doing it just like right now yet, but you can also accept LP tokens or anything else that is yield bearing. So you could have USDT, USDC, DAI stable swap pair, which might be quite interesting and lucrative in terms of like the trading fees. For the interlay system, it's a quite good collateral because it's a mix of different stable coins, works fine. You could also, and that's where it becomes really exotic, try to pair like different assets together that are not correlated, like don't have the same price. That becomes that's then more already, more difficult to kind of measure.
Cool.
But that's essentially the way to resolve the capital efficiency issue. So you allow people to reuse the capital. And this is also the reason that one of the reasons that interlay now has its own DeFi hub, which plugs into the bridge. For users, it means that, you can do one-click things. So you want to swap for USDT or you want to borrow USDT and maybe off-ramp it. And in the near future, you'll be able to do that by just sending Bitcoin to a deposit account. Everything else is automated, and you get USDT, let's say, ideally onto your credit card. That's like you swap USD for actual USDT for USD, and you have it on your credit card, which you can spend. That's like the optimal outcome. And for vaults, it's quite nice because it's tightly integrated with the DeFi hub. So with trading and lending, where they can reuse their positions, quickly liquidate, quickly rebalance. Yeah.
Cool. No, sounds good. Yeah, I mean, a lot of the collateral reusing can get risky. Makes me nervous, but I think I'm odd in that sense. I guess the one question I did think about for this is like, do you guys limit this size at all for Bitcoin? Because obviously, like I know we were talking about the block confirmations, but like theoretically, like if this got really big, you could, you know what I mean? Like it's not that expensive to break Bitcoin's proof of work for, 2 hours. Like you could easily, if you had $10 million in here, or do you have like limits on withdrawals in that sense?
So right now, so this is something that you do basically as a system grows, right? So right now there's limits set by how much collateral is in the system. So it's similar to how like Compound or MakerDAO have ceilings for each collateral asset, so does Interlay. And these ceilings, obviously, they determine how much Bitcoin can get in, right? If you have a ceiling of collateral, let's say $10 million worth of collateral, averaging, let's say at 150, like this means maybe you can only do $7 million worth of Bitcoin, right? So there's always, so that kind of, you increase the limits as you go. And obviously, as this grows, it makes a lot of sense to have variable confirmation times. So for small mint requests, you're fine with 6, or like you can also do work on models that allow you to go even faster. So if your vault is happy to take up the risk and just confirm and say, yeah, sure, I'll vouch for the Bitcoin arriving. And then you can do instant minting, not live yet, but something that we're looking into. But for big amounts, right? And if you have a lot of like Bitcoin coming in and out, it makes sense to rate limit and impose like longer confirmation times, 100%. Like that's something I think we will see in general in bridges across different chains, and it's a very sensible mitigation.
Cool. Yeah, no, because it's like I would say like if you wanted to, and I mean you're probably limited by what you can use IBTC for as well, like how fast that you can exit. Like if there's not a whole lot of DeFi stuff going on IB or on Interlay, then there's not really much risk in minting it really fast. But
the risk increases as the system grows. Yeah, exactly.
For sure.
But what also, like if you fake mint a lot of IBTC, like what are you going to do? You need to. It's possible to execute, but the nice thing is Bitcoin is just slower. So it's not like with like things like Nomad or like instant that you just see the thing getting drained really quickly. Bitcoin is just slower confirmation time. So yes, somebody can pre-mine a fork, submit it, but they have to wait for confirmations, and they have to definitely wait for an hour. And within this hour, we'll see like red lines going on, and like, oh no, like somebody's attacking. And then you can actually, you just can freeze all the pools or like interfere, like govern. I mean, it is still a challenge because community has to come together and vote on doing something. But at least other protocols can react and say, oh, well, maybe we'll close off the bridges for this time being or something like that. Make it super difficult for the attacker to do it. Yeah.
Well, I mean, that's like, now in Ethereum land, like basically, you're not going to get like the full value of whatever you hack out of it. It's basically limited to like what you can drain Uniswap pools for. So it's like it's not even if you steal $10 million worth of a coin, like if the Uniswap pool is 500 grand, you get 500 grand. It's kind of the way it is.
Yeah, exactly.
Okay, cool. No, I like the Bitcoin one. And then I guess you were saying this works similar to vaults. I have to at least ask, like, if it starts getting under collateralized, what's your collateralization ratio? And then like if it starts going under, I'm guessing they have to top it off or get liquidated in some way.
Yeah. So there is like, it's similar, but there is one slight difference to like DAI. So the collateral ratios are set by governance. I mean, we do risk assessment. There's an R team and there's in the community people who look at this. We use the same models that, for example, Gauntlet uses, slightly extended. Basically look at that. So collateral ceilings right now are between 150 and 155%. I don't remember which one is which for DOT and USDT. If a vault starts getting under collateralized, there's like multiple stages of things that happen. So ideally, the vault just, is able to store some IBTC and self-redeem. So close out its own position, just unlock a bit of the collateral, make sure it's available. What happens next if the vault, continues getting under-collateralized is the system triggers a so-called premium redeem. So you see that in Liquidity protocol, for example, where they pick the lowest collateralized, vault, which you can redeem with. Similar here, a user is incentivized to redeem against the low collateral vaults, and you actually get a premium. So you actually slash the vault a bit. The vault pays a small premium to you, small percentage, to help them rebalance. So if they are unable to do it themselves, users or liquidators can come in, source IBTC, and then redeem against these low collateral, like vaults that are not yet liquidated, but are like struggling to keep up the ratio. And if that doesn't work, then at some point you're liquidated. And then basically the system just says, well, fine, keep the Bitcoin, we'll take your collateral and offer it up at a quite sweet premium to anybody who wants to trade in their IBTC for the collateral assets.
Yep.
And the penalty right now is 10%. So it's quite high to really disincentivize people trying to, kind of float close to the lower levels. One interesting difference, though, to DAI is, well, it's similar. Well, so DAI without, this USDC peg had no way to really kind of easily peg back to the dollar. Whereas in IBTC, the vault has the Bitcoin. So if your vault is, struggling, what you can do is like either buy IBTC, but let's say you don't have any extra capital available. So what you can do instead is you take the Bitcoin that you're actually safekeeping and try to swap it for USDT or DOT, and then buy IBTC in the market and then redeem. So you kind of try to use the Bitcoin that you have available to go like basically circumvent and come from the other side, get IBTC and then self-redeem. So that also is possible.
Nice.
So it would be like selling your DAI. Yeah, like
that
doesn't work with like stable coins.
Sort of, but yeah. So I mean, you could. Is there an interlay stablecoin?
No, not at the moment. No,
not at the moment.
We've been asked many times if we're going to do a Bitcoin-backed stablecoin, and it certainly is possible.
Well, I mean, you got like the whole structure set up, right?
Yeah, it's all there. It's all there. But the challenge with stablecoins is it's not building it. I mean, yes, you need to take one of the models that we know are like collateralized, over collateralized. There's a few pretty good models like this is similar to MakerDAO. But then what? Like you need to get people to use it. You need to have like this whole business model set up and like integrating everywhere. And we're right now observing what's going to happen with like Curve and like Compound and maybe Aave, everybody doing their own stablecoins, and we'll then see. So right now we're more focused on enabling others to build on interlay. So we launched the DeFi hub. So that was actually very recent. You can now trade, borrow, lend directly in interlay. And now the goal is to allow other people to build on top of this and just provide them with the tools. So somebody could come along and deploy, use a lot of these tools to just mint a Bitcoin-backed stablecoin. And then, so we don't want to centralize everything around our team. We want to collaborate with other teams and make sure if there's a team that specializes in stablecoin design, better they build that than us doing Bridge and DeFi hub and build this platform and stablecoin. It just you grow around this rather than growing one big company. You want to kind of collaborate with teams that really specialize in their verticals.
Yeah, for sure. So and then let's talk. I know we're like 45 minutes already, but what's how do you guys connect to other chains? Do you connect to other chains?
So yes, we do. And we will definitely more in the future. So right now we are being part of this Polkadot ecosystem. We can talk to all the Polkadot parachains, and because it's all secured by Polkadot's consensus, that's quite nice because we don't need to really worry about building bridges there. So it comes basically out of the box, and you have things like HydraDX, which is a quite unique decentralized exchange. Their treasury is building up Bitcoin positions. So it's quite we're seeing more and more integrations on the DeFi and DAO side, which is quite exciting. But then obviously, like, okay, we need to connect to Ethereum. We also want to connect to Cosmos and like Avalanche in the future. How do we do that? So, and here is where like being on Substrate is quite beneficial. So there is a Cosmos Substrate bridge in the works. I think one actually went live a few days ago.
Okay.
Where you can now bridge from Substrate chains to Cosmos chains using IBC.
Yep.
As this expands, basically what the end goal is that any Substrate chain like interlay can look like a Cosmos chain, and that you just talk to each other, use like clients, and that's the best way to do it. Maybe Cosmos adds shared security, we don't know, right? How that will work in the future, but in the end, IBC is a pretty good way to talk to Cosmos chains. And there are implementations being finalized with first, I think, being deployed. On the Ethereum side, Polkadot has been working on the first like truly like client Ethereum bridge for a while now, and it's due to go live this year, which basically would mean either we connect to that or we deploy an interlay, but essentially you'd have a like client for Ethereum, and Ethereum has a like client for Substrate. And then you have a like client to like client bridge, and this is just the best way to do it. So I spent actually my PhD focused on building cross-chain bridges. We showed that it's actually impossible to do it completely trustless. And the best way to do it is you have to trust someone, and you need to incentivize that they behave correctly. So in the Bitcoin case, it's pretty clear you incentivize the vaults. In case of Ethereum to Substrate, both can do smart contracts. You can really minimize trust by having the like clients. So they verify each other, and you just need to incentivize the one person that submits the data and the proofs to actually keep it alive. And that's the best bridge model that we can do on Ethereum and other chains. And my bet is in 5 years, you won't need centralized bridges. Like you'll have like client to like client bridges between all bit networks. And that's the bet, right? So we're integrating with some of the bigger kind of, I guess not, it's unfair to call them centralized, but like distributed big like multi-threshold SIG bridges right now to just support them out of the as well, and like allow people to choose. But long-term, the goal is interlay stack supports the development of like client bridges to Ethereum, to other EVM chains, and to Cosmos. And that's the goal, to collaborate with existing teams that have been building on those for 2 years now, actually, and to use that to just get IBTC to Ethereum, to Cosmos, and so on.
Nice. Well, yeah,
there are also other ways.
Yeah, no, it's an interesting one, because like it sounds like in a lot of ways you'll be piggybacking off of kind of the Polkadot's bridges, hopefully. You know, like hopefully you guys aren't developing necessarily the like client to Ethereum. Hopefully you guys can just sit and use Polkadot's, right?
So it's being tested. It actually we've helped also a bit like with like getting auditors for that. So it's really looking good. But there is an alternative, right? So there is always the alternative to just roll up, right? It's not as secure as a like client bridge, I would argue, or like
what, just be a roll up to Ethereum? But
you can always expand and like there's like a Substrate like there's Madara. It was a project that built a sequencer for StarConnect in Substrate. So there are ways to basically also roll up to Ethereum. That's a very early field of exploration. That's an alternative. So you can either use the like client to like client bridge through Polkadot, or deploy one directly on your own chain, or you try to roll up, which is very similar, basically, right? But the difference.
Yeah, so what would you say is the difference between like a like client bridge and a roll up?
It is quite similar, with the difference that like Ethereum isn't really aware in that case. So Ethereum doesn't like. So with the like client bridge, the smart contract on Ethereum actually verifies the consensus of Polkadot, which is obviously a much more decentralized consensus than just a sequencer telling you, yes, I got the block, right?
Right.
So with the rollups, you have like a sequencer. It's like me getting the data and then rolling them up, and ideally you can exit. So that's the difference.
Well, like with the ZK rollup, you would say it does, right? Or
with the ZK rollup, you validate the correctness of the transitions, but then the question that I think it burns down to the exit strategy. With a like client bridge, if something breaks, how do you exit, right? There is no easy way to exit. There's no way to kind of just, grab your assets and flee. With a rollup, there in a certain scenario, they're not in all scenarios, right? Because if you've supplied into lending on an L2, yeah, that's it, right? If something breaks, like there is no easy way for you to exit. So the exit scenario works if you want to get your ETH out and you just have liquid ETH. You should hopefully, if the L2 that you're using has this properly implemented in a secure manner, you should be able to exit back to the main chain.
Big if.
Now I say all this because if you look at L2 beat, which is a quite good indicator for these things, it's, we're not quite there yet, but hopefully soon in the future. And then you basically, you have these two different models, but they're very similar. If you really inspect, and you're right here, of course, it's quite similar.
Yep. Yeah. And I mean, what would you say, like, like it's always interesting to see, like, if you guys go through the Polkadot's hub, like where do you see sort of the bridge? Do you see it as being these hubs and spokes, like Polkadot will connect to Ethereum, Ethereum will connect to Cosmos, and then you guys all just use XCM in yours, or is there some better way to, like, actually, like if you have thousands of app chains in the future, are they all going to route through Ethereum? Like, won't that get nice and pricey?
I really think it depends. So right now, for a chain like interlay, it makes sense to bootstrap, right? So, and
Sure.
In our case, we like Rust, we like the substrate stack. It allows us to really plug into Bitcoin. So we work on Polkadot, but we also obviously want to connect to Ethereum because that's where the liquidity is, and most users are, obviously. So there's like bridging through Polkadot to Ethereum is one option, or you roll up, or you can, that's the two options there. Long term, and I think that's what we'll see with many app chains, is if you become big enough that you can be standalone, right? If interlay grows and there's more people building on it and it keeps growing its community and becomes big enough, then you need to think, okay, do you stay plugged into something else like an L2, or do you become a standalone chain that just has if you're big enough to spin up your own Likeline to Likeline bridge, to have the capabilities to do that, and to maintain that Likeline to Likeline bridge, and to bootstrap your own validator set, either your own proof of stake network, or you merge mine, or you do merge mining and merge staking, or there's like tons of ways how to do that, like how to run your consensus. If you're big enough to have resources to allocate to that and build out your own set, then you just become one of these. You can be standalone if you want to, right? And then others might be plugging into you. I think that makes sense for really big projects that have product market fit, thousands and hundreds of thousands of users, or maybe even the millions, where you want to minimize your dependencies, and you're pretty certain that your community in-house can build all these bridges and the infrastructure. That makes sense. Think of let's say Avalanche. Avalanche will not plug into Polkadot or Cosmos, right? It's a big enough standalone network that has its own consensus, has its own subnets, so they will just be their own thing. And with app chains, they all could grow potentially to that size.
Okay.
And then whether it's connecting to Ethereum, yeah, we'll see. Like with gang sharding, I think Ethereum is also moving into this, like enabling pretty good alternatives to app chains. So yeah, we'll see.
Yeah, I mean, do you see then people starting as like Polkadot parachains, and probably even, like, I've heard this thesis before, like you'll start as a roll up and then move into an L1 if you succeed, like, or is that not the case? Like because what's the trade-off, I guess, with a roll up, or is you lose some of that sort of sovereignness, if you will, right?
So I think, I don't know, but I think DYDX is one to look out for, right? So they went through that journey somewhat, right? Yep. So they weren't really a roll up, I guess, not really, but then they're now standalone sovereign. They want, yep. Yes, you have like option order books and everything, but then they're a standalone chain. And let's see how that works out, because you are separating yourself. If your community is big enough to sustain a product, and you're not dependent on people, users just hopping and your product being composable with one click, then it's fine. But the thing you lose if you go standard, like a multi-chain environment, is you lose composability.
Right.
Like it's much more, it's XCM and IBC and these things in the future will enable it, but it is it's quite a bit more sophisticated. It's not like, oh, I'm making a contract call. No, it's like I'm calling a contract on another chain, and then somehow I need to be sure that it executes, and I handle failures. If that thing doesn't execute, then I need to roll back or something. On Ethereum, on one chain, you don't have that. You just call one contract, call the other, and if one error occurs, automatically you can roll back. With multi-chain things, we don't have any automatic protocols to handle that. There's like things coming up, new projects trying to do that. But right now, if you want to do like multi-chain contracts today, you have to do everything yourself. Like you really have to hack together your own rollback and like build your own two-phase commit protocols and everything. So yeah, XCM and IBC go in that direction. XCM is pretty interesting because it allows shared security. It allows you to trust much more in the protocol, but it's still not that easy to do as like on a single chain.
Right. Okay, well, so we're like at an hour already, but I would say we'll go back to interlay actually. And what's next on your guys' roadmap? You know, like, so you guys have the Bitcoin bridge, you know, you have DeFi apps being built on the interlay chain. What are you guys looking for? Where are you going next?
So our next step is really to decentralize in the sense that we don't want to be the only ones building. We have people approaching us and like wanting to extend the system, and they should be like teams should be able to do that without asking the interlay governance. So the goal is to enable smart contract functionality. Now the question is which one, because there's different VMs, right? Decision one, there is no way, at least today, there is no way that leads you around EVM support. Everything else like is still kind of skewed towards EVM compatibility. So that's definitely something that you'll have an interlay just so it looks and feels like any of the L2s. That's like the first thing that's happening right now, because although we love Rust and Substrate, it's just you always have this fight of you have to change your behavior as a user, and that's just putting another extra hurdle for adoption. So we don't want that. So we want users to, it should look and feel like Ethereum. But then that's compatibility. So you'll be able to deploy contracts, but what we really are interested about is Rust. So coming from Bitcoin Corner and all the new stuff on Bitcoin being built in Rust, we're pushing and we want to release like Rust-based smart contracts. So there is something called Ink, which is already used by a few substrate chains, which allows you to write smart contracts in Rust. And I'm pretty bullish on Rust as a whole, like ecosystem community, and seeing like just imagine like you're building on Bitcoin today. You kind of, you know, either if you're not building in script, but you're building like things around it, like Lightning nodes or Nostr servers or like ordinal indexes for BRC20s and so on, you know, you're using Rust. Now imagine you could take part of that code and put it into a smart contract to just remove single points of failure, add additional functionality, and decentralize it. And that gives you benefits in terms of A, security, B, of course, regulatory concerns, like how much control can you have? Do you want to have all things like that, especially when it comes to peer-to-peer trading of Bitcoin against fiat? And then it comes with all sorts of other benefits. If you look at local Bitcoins getting shut down, Paxful having issues, there's a lot of startups trying to move into that field, but dealing with bank transfers and the fiat world was very painful, especially as a startup. But what if you could settle in stable coins and use these dozens of off-ramp providers to just send your users to that? Like you don't deal with the off-ramps, you just focus on your product. So that's the opportunity we see there. And you know, being able to use Rust, you just can plug into the Bitcoin libraries and reuse a lot of the things that's already there.
Cool. Yeah, no, Ethereum's getting some Rust community as well. You know, it's definitely starting to grow. So I might have to learn Rust here sooner or later.
I mean, quoting Dom, like my co-founder and CTO, so you know, like parts of the Linux kernel are being rewritten in Rust. If it's good enough for the Linux kernel, it definitely is good enough for our smart contracts.
All right, yeah, you heard it here first. So this was great though. You know, we can kind of wrap it up. You know, where can people go to find out more about interlay? And I guess you're looking for, if people are looking to build on interlay protocol, you're trying to launch a DeFi app, it's a great place to go, right?
Yeah. So if you want, I mean, if you want to use your Bitcoin, like borrow or trade it, you can go to app.interlay.io. If you want to build, then go to interlay.io and then join our Discord, talk to us. We'll have a testnet pretty soon. And yeah, we really look forward to onboarding more builders and, you know, starting to work together with other teams.
Super cool. Yeah. Well, thanks for coming on. Talk to you later.
Thanks for having me.